All right, we've got both data charts here that we got from our work on the lab, the refraction of light through different media, and we're going to look at the analysis questions A through G. Question A reads, did the refracted ray bend towards normal in the water in the vegetable oil? So you can see all the angles of refraction for the oil are less than the angles of incidence, and all the angles of refraction for the water are less than the angles of incidence as well. So light did bend towards normal for both mediums. Question B, with the exception of an angle of incidence of 0 degrees, compare the angles of refraction for water and for vegetable oil for the same angles of incidence. So you can see for oil, 10 becomes 8, 20 becomes 16. For water, 10 becomes 7, 20 becomes 15. For oil, 30 becomes 23, 40 becomes 31. For water, 30 becomes 22, 40 becomes 29. So it looks like the angles of refraction for the oil are slightly greater than the angles of refraction for the water, which means the light was bent towards the normal a little bit more compared to the angle of refraction. Question C, what do your results tell you about the speed of light in water or in vegetable oil compared with the speed of light in water? So we go just on our data. If light is being bent towards normal in a greater fashion here, that means water's slowing down the travel or speed of light here slightly more than it is there. All right. Question D, in which medium, water or vegetable oil, did the speed of light slow down more? Well, I just answered that. It's in D, because we're getting the angle of refraction to be slightly smaller, which means we're getting the light bending towards the normal more compared to what we saw for the oil. And then G, could the method used in this activity be used to distinguish between two liquids that appeared to be identical? And absolutely, all you have to do is just follow the procedure that we just did. Send a bunch of incident light rays through the material, and then measure out the angles of refraction. You mathematically analyze it like we did here. Calculate the signs of the incident rays, the refracted rays, those angles. Do the ratio sine I over sine R. Figure out what the index of refraction is, and then you could probably look it up in a chart to see what you actually have. Okay, and that's it. Questions E and F pretty much ask you to do some calculations, which we did already. Okay, so good procedure for determining what the index of refraction of a substance is, and identifying it based on known values which you can look up in charts.